The Great Attractor, something is pulling our galaxy toward it. The universe is expanding. In the century since Edwin Hubble demonstrated that galaxies are moving away from each other, cosmologists have built a detailed model of a universe where everything is receding from everything else at a rate proportional to distance, the Hubble flow. But within this general expansion, individual galaxies and galaxy clusters can have peculiar velocities, motion that deviates from the expected Hubble flow due to local gravitational influences. In the 1970s and 1980s, astronomers began noticing something strange about the peculiar velocities of our local region of space. Our galaxy, the Milky Way, along with the Andromeda Galaxy and dozens of smaller galaxies, form what is called the local group. The local group, along with hundreds of other galaxy groups and clusters, forms the Virgo Supercluster. And the Virgo Supercluster, along with thousands of other galaxy clusters, forms a structure called Laniakea, a supercluster 500 million light-years across. All of these structures, from the Milky Way to Laniakea, are moving in the same direction at high speed toward something astronomers call the Great Attractor. Great Attractor is located approximately 250 million light-years away from us, in the direction of the constellation Centaurus. The problem is that it sits almost exactly in the plane of the Milky Way's disk, in the region astronomers call the zone of avoidance. The zone of avoidance is the band of sky obscured by the Milky Way's own dust, gas, and stars, which blocks most wavelengths of light from reaching our instruments. Whatever is at the location of the Great Attractor, we cannot see it directly in visible light. Using radio waves and X-rays, which penetrate the zone of avoidance more readily than visible light, astronomers have identified a massive concentration of matter at the location of the Great Attractor, a supercluster of galaxies called the Norma Cluster, or Abell 3627, embedded within an enormous concentration of dark matter. The gravitational pull of this structure is colossal. It contains the equivalent of tens of thousands of Milky Way galaxies, and we are being drawn toward it at over 22 million kilometers per hour. But here is the deeper mystery. Even accounting for the mass of the Norma Cluster and all the visible matter we can detect at the Great Attractor's location, the gravitational pull is stronger than the observed mass should produce. Something additional is pulling us. Either the zone of avoidance is concealing even more mass than the radio and X-ray surveys suggest, or there is significant dark matter concentrated there beyond what models predict. Or we are missing something about the gravitational structure of this region of space. In 2017, a team of astronomers led by René Croncourdueg conducted deep surveys behind the zone of avoidance using the Parkes radio telescope in Australia. They discovered hundreds of previously unknown galaxies hidden behind the Milky Way, including several large galaxy clusters directly behind our own galaxy. The discovery significantly increased the known mass in the direction of the Great Attractor. But even with these additions, the gravitational budget still does not fully balance. More recent research has expanded the picture further. The Great Attractor itself appears to be falling toward an even larger structure, the Shapley Supercluster, located approximately 650 million light-years away. The Shapley Supercluster is the largest known concentration of mass in the observable universe. Our galaxy, pulled toward the Great Attractor, is caught in a gravitational flow that is itself caught in an even larger flow, like a river flowing into an ocean, flowing into an abyss. We will never reach the Great Attractor. The expansion of the universe is accelerating, and the increasingly rapid expansion will eventually carry most distant structures beyond our cosmological horizon. We are being pulled toward something we cannot see and will never reach at millions of kilometers per hour, embedded in flows of gravity that extend hundreds of millions of light-years, nested within structures we are only beginning to comprehend. The universe is very large. The forces in it are very old. And the Great Attractor is simply the nearest evidence that we do not understand our neighborhood in space as well as we thought.